I think some of you recognize a few faces that you were at the previous talk already about MLS. Some of you maybe weren't, but some of it might sound familiar from you if you listen to this talk. But to get the important stuff out of the way, to make some mayonnaise, you take 1 part of unflavored, unsweetened soy milk, like this is a vegan variant. You take 2.25-ish parts of canola oil, for example. If you take a bit more oil, it will get a bit thicker. You take 0.1 parts of vinegar and lemon juice, and a bit of salt for taste. And then the important part is that you put everything into a container that's slightly wider than your immersion blender, and then you just blend it until it's like mayonnaise. Thank you. No, but like actually what's the point of this? So mayonnaise, because I did physics previously, it's like an emulsion where you mix basically water and oil, which sounds like something you couldn't mix, but like that's exactly what we're also trying to do with MLS and Matrix. So I thought, well, this is a perfect analogy, and I'm always hungry, so and I also wanted to share a mayonnaise recipe. So what's the point? Matrix and MLS are incompatible, but yeah, let's explain a bit about that more in detail, and maybe we can figure out some paths to a solution, even though I have no solutions for you here, but maybe some answers at least. First, a bit about me. I'm Nico. I tend to make bad jokes. That's actually the official title at the company that I work at. You can find my MX ID there if you want to message me, but usually I won't answer unless you've previously talked to me. I develop a Matrix client in my spare time because I didn't like the other options at the time, and now I've been doing that for like 6 years or something. It's all a bit of a mess. I'm also now part of the Matrix governing board, representing the community there, and trying to push some things forward that you might not see as much about. But if you're interested in that, I will also have a talk about it tomorrow. I currently work for Family. We do Matrix for the healthcare system because we thought it's dumb that all of them use WhatsApp, or even worse, they send faxes with your important data, and then it ends up in the wrong basement of some person, and someone needs to go over there to fetch the data then, because they can't delete it otherwise. And my biggest achievement so far was that I got rid of reply fallbacks in the Matrix specification. You probably don't care about that, but it took a lot of effort to just delete a few lines of specification, and I'm very proud of that. And now currently at Family we're trying to bring together MLS and Matrix because the BWI has requirements that they need to do that, and someone needs to figure out how to do that. That was a bit long, and it gets longer every year, but whatever. Let's go to actual talk. So what's this Matrix thing actually? Like, we could try to bring MLS and Matrix together just by smashing it together, but we probably want to keep some properties of every system, and so we probably want to figure out what the system is actually at its core. And if you look at Matrix, the first thing most people will probably tell you, well, I have state resets. So the cool part about Matrix is that you have this fancy state resolution that can give you state resets, because that's actually a property that you sometimes want. You want to be able to remove malicious state from a room by an administrator having sent the correct state, because that allows you to have an open federation where basically everybody can participate without you having to allow list your server, and then you can just communicate with each other, and that's really cool. But you don't need to rely on a central server that someone hosts or ask them for permission to link up your IRC channel to them. You can actually just participate in a room and hand out permissions to everybody, and this system kind of works. That's cool. It also is really fast. Now, maybe not in practice, you might disagree there, but in theory, this way that Matrix works is that it just works optimistically and resolves conflicts later. Means you don't need to wait for some consensus to form between 1,500 servers where half of them are offline. Instead, you can just go forward, and if there's a conflict, you can resolve that maybe 12 months later down the line. This actually works kind of that it's ordered by power level. So if you are the admin in a room, your server is more trustworthy than the other servers in the room. So there's actually a power relationship, and not every server is strictly equal. But in theory, you can just hand out those permissions to other servers and transfer ownership and whatever. You just kind of need to ignore some other stuff that's currently working on, like room version 12, where now the creator can't give away their power, and policy servers where you have a central server that can just delete events from the room. But if you ignored it, then you basically have a completely decentralized system where you don't really have a central control. It's also really partition tolerant. You have no network connection between servers for ages, and then they can come back, and suddenly all the messages backfill. They might be in the wrong order, and you might be confused about it. But in theory, you can have an arbitrary amount of no network connection between servers, and later the system will recover. It kind of also then causes problems that, like, if you have old membership events like the Matrix HQ, 100,000 users already left that room, but all of their state events are still in the room, because we need to somehow tell people that the user is not in the room anymore. And because of the state resolution, that always needs to be kept around, and you have then, a few hundred megabytes to gigabytes of state that you just need to carry around with. But that's kind of the cost of that we need to pay for all of the other stuff. Another cool thing about Matrix is that it has somewhat nice APIs. You can write basically a Matrix client with just curl commands. There are Matrix clients written in like a few lines of bash, and that's kind of really cool. We can make a lot of stuff work with very simple tools. It's easy to introspect, and other systems have way more complicated APIs where you need some weird binary stuff that you need to send around, and for Matrix you just post some JSON to an HTTP API, and that's works and is like a lot easier to work with. And Matrix also kind of, I will get a bit more into that later, but like Matrix basically is a history sharing service, but it also includes like a directory service where you can actually look up users or rooms, and then basically find other people and start communicating with them. So it's not just about exchanging messages, but you also need to like find users, and also their one-time keys that you might have heard about before. Then also it has encryption. It uses that via sender keys, double redshift stuff. I'm not going too much into detail how that actually works. But there's actually kind of two layers of encryption in Matrix, but we mostly, if you look at it from a security perspective, we just look at the double redshift, and that gives us some encryption properties that we care about. One problem with Matrix is that, well, a lot of the state is resolved on the server side. So membership is effectively controlled by the server, which means you don't really know who, as the client, if you say, okay, only my end-to-end device is trustworthy, my client that I have on my phone, it can't really tell who should actually be in the room because it's server controlled. That's kind of a problem when you have end-to-end encryption, because there you want to have verified that this message should only go out to the senders. You can of course solve that by giving a pop-up every time, do you really want to send this message to these users? But that's not usable, so most clients don't do that. They only tell it to you when a user isn't verified. But that doesn't really solve the problem. If you verified 5 users, those are still maybe not the users you want to send a message to currently. So that's currently not a solved problem in Matrix. And there's also the problem that, okay, we can resolve state like 12 months back into the past, but we might, as a result, have messages we can't decrypt because state wasn't exchanged at the time and people saw a different membership, and that does cause then usability problems or encryption problems that might be not something you necessarily want. And it's also really hard then to troubleshoot, okay, why can we not read this message? Because it might be like the information isn't there in the event, that you can't really see that. And then another big problem we have with the end-to-end encryption matrix is that, well, the state is currently unencrypted. So if you put when you're meeting for your secret, I don't know, install Linux party or something somewhere and put it into the room topic, then anybody on your server can, any one of your server admins can basically get that information. And most Matrix clients don't even tell you that. You put secret information to your room topic, your room name, and you don't even know that you just leaked data. So that's probably something you want to fix, but it's not that easy to fix because messages and state have a different lifetime. If you set the room name, that will still be the room name possibly in a year, but the messages and you invited someone new into the room in the meantime, and they should still be able to decrypt the room name, but they shouldn't be able to decrypt the messages back then. So you have different key schedules to deal with, and that gets kind of messy, and there's no good solution yet for Matrix on how to approach that. And it's not just the state that's unencrypted. There's also a lot of metadata that's passed around there between servers that's not encrypted. Like anybody can see who sent a message in a room or who's the admin of a room. And that's fine if you're just communicating on your server to the server of a friend of yours, but it's something you might want to avoid if you're sharing like public servers, or if you don't want to consider your server trusted in any way. And then there's also a technical problem with the end encryption matrix if you have the online key backup, because technically that breaks perfect forward secrecy, because you only have one key to access all your messages, but that's more of a technicality and you mostly don't care about it because you want to read your messages, but just for completeness sake. Then there's also a complexity thing. If you encrypt a message in Matrix, you basically need to send the key for that message to every device in the room, which means you basically have a linear complexity. If you have 10,000 devices, it might get slow in your client, or I don't know, in my case, 100,000 devices. That means that it will take a few seconds possibly to send the message sometimes. So that's might not something we want to have. Maybe we want something more efficient. Now, to contrast this, MLS is a completely different way to do encryption. It's an IETF standard, which for some people is really important, for others it's not as important, but in general in Matrix we do kind of like if we can rely on a different standard instead of having to build our own. That's why we have OIDC in Matrix now. We don't want to build our own authentication system if there's already good solutions. We want to have someone else do all the work for that, and we just use it. And maybe there's a benefit to doing that for encryption as well, if the encryption fulfills all of the requirements that we have for it. Problem with the with MLS, it only does encryption. There's no message format or server API, so you need another system to use it. Mimi might be a solution for that, but we are here for Matrix, so obviously we want to do Matrix in some way. There's also, for the customers that I have, it's important that it's BSI approved. That's basically the only way you're allowed to send a certain kind of state secrets or something, and so they need to make it work somehow. Most of the people in this room might not care about that. Then we last talked about the complexity. In theory, MLS can have logarithmic complexity when encrypting, which means for big groups it should perform faster. That's just not always the case. So there are edge cases where it actually degrades to linear complexity, so it's not necessarily all roses on the other side, but in theory we can make get a lot faster for large groups. Then one of the key things in MLS is that you have two sets of messages basically. You have normal messages that are just I'm sending you a text message about what I'm doing tomorrow, and then you have handshake messages, which are anything that might affect the encryption in the encryption keys. So when you add a new member to a group, when you kick a member of the group, when you're just updating your keys so that they have more entropy or something, those are handshake messages, and those need to be globally ordered. So we can go perfectly centralized as long as we never change the membership in a room. But if we want to change membership, then we need to solve some disordering problem somehow. Another thing that MLS does different is that it has one trusted set of users in the room, which might be something you want. You want everybody in the group to talk to the same people so that you don't have someone accidentally leaking details of a conversation to someone that you're not even aware that they are in the room currently. So, but that's a choice, and I'll go a bit into that later. Another thing that MLS does is that it basically allows you to derive keys from the way it does encryption that you can then use for other purposes. That might be very useful. I'll tell you about some cases where you maybe can do some fancy stuff with it later. And then one thing already mentioned in the previous talk is we have this shared group context. This allows us to put arbitrary data into it, and that means basically we get encrypted state events for free. In Matrix, we've spent a lot of time trying to figure out how to solve it. If we were using MLS, that part is basically for free. And so if we can figure out how to do that, we can then avoid another problem where we would have to think about it. So the less important differences here between MLS and Matrix is that how the we basically set the target for of the encryption. It doesn't matter that much if the sender decides or the whole group basically is set on one set of recipients for it. There's arguments for both, but I think in the end this is more of a choice what you want there. It's not necessarily that one is strictly better than the other. It's also, like I said, well, Matrix has like multiple layers of encryption, but in theory we don't care about it. If the layers work perfectly, we will never get to see them, so who cares? Multiple layers, whatever, it would just work, so what do we care about it? Then there's also the way that Matrix does state and the way that MLS has like proposes to change state kind of works a bit differently. One like basically overrides stuff, the other one does like incremental updates to things. So there's a bit of a difference there, but in the end, for the end user, both of them work, so we also don't really care. The big problem and why we need a blender to bring them together is, well, we have on the one side we have decentralized state resolution where you can add on any server, even if it has no internet connection, add new members to the room, and later it will somehow work, versus in MLS where it's just not possible. It's strictly speaking illegal according to the specification, so we somehow need to take a knife to something to make that work, and the blender has a lot of sharp knives, or well, not sharp knives, but it at least has a lot of knives that move very quickly, which can sometimes be very useful for mixing stuff. And this centralization requirement basically is a requirement to do this one shared context for the and the one shared membership, because if you have decentralization and you updated the state on one end, you clearly have a different context than the other people who haven't updated it yet. So this kind of constrains us in what kind of solutions we can build there. And then there's also that state resolution. If you can go arbitrarily back and need to resolve the state that someone there added a member back then, this basically compromises your perfect forward secrecy. If someone could tell you that now that they added a member 2 years ago, that member should be able to read all the messages, then you have no perfect forward secrecy. Currently, that's actually not the case in Matrix because we are not sending those users usually the key. But if we wanted the users who get added there to actually read the messages of when they were supposed to be added, then we wouldn't have perfect forward secrecy. And yeah, MLS basically tells you, well, as soon as you change the set of users, you should throw away all of the old keys so that you basically guarantee these security properties, and you're not allowed to keep them around indefinitely, because that then someone could derive the secrets for any of the points and read all of the messages when they ever compromise your old device. And we don't want it. If you lose your phone, you don't want someone to be able to be able to read all your future messages. You want them to be somewhat removed from the group and not lead that to a compromise, even if you might not be aware of the compromise. This is one of the big things that Signal did back then, that it basically automatically heals based on a compromise, and we kind of want that property. So let's just imagine we could do whatever we want and make it work. Like we had infinite funding and possibilities and whatever. What is the stuff that we actually care about in our messaging solution? I think the most important part is that we want to have secure and private messaging where everybody is basically in control of their own data. We don't want our data to go to Facebook or something just because I send someone a message. We don't want to leak have all of our messages be publicly posted on our blog or something. We want that to be private. We want it to be secure, and we want to be the ones who are in control of the data instead of someone we don't trust. We probably also don't want old devices to compromise all future history when they inevitably get broken into. So some kind of forward secrecy we probably want. But the question is, how strong of a guarantee do we want there? Do we really not accept it if they're like a 0-second lag of like forward secrecy, or is it maybe fine if it takes 5 minutes for until the messages become unreadable for the device? Maybe it's also 30 days. That's an option there. I think there's different security contexts where different solutions might actually be acceptable, and that might be something you want to control, and depending on how much centralization you have versus how much security you have in theory. Another thing is, does the server actually need to know who's in the room? Currently on Matrix, that's just required so that you can enforce permissions, but if we had our perfect messengers and we could somehow solve the permission thing otherwise, it might be desirable that the server can't really tell who's in the room, and instead it's just an arbitrary forwarding proxy for you, and yeah, basically similar to what Signal advertises with its sealed sender, that, well, we can't tell who's talking to whom, and like in certain contexts it maybe you want it in like your company or something, that you can tell who's talking to whom, but in a really private messenger you probably don't want it. Do we want the best privacy? Like it's the best, so clearly we want it, but yeah, that might be desirable to go a lot into the privacy direction. And yeah, do we want those state resets where suddenly the name of the room is the one from 2 years back because some old server came online and had some conflicting state? That's usually not the state reset we want. We want the ones that are short-lived, where someone did maybe something that they shouldn't have been able to do and we fixed that in post. But if it's like 2 years back and we were using the room fine, and then suddenly I'm not an admin in the room anymore, the room name is the old one, the avatar is gone, and the topic is something irrelevant, that's probably not what we want. So maybe we could actually time-bound the state resolution that we have. And another question is, okay, what permissions does the server actually need to enforce? Do we need to enforce specifically which kind of message a user can send, or should we just enforce if a user can send a message into the room? And so if we can play around with that, we are also very flexible in which kind of solutions we can build. So I'm just going to be radical here, and we'll see if it works out. Let's just remove the senders from events because we don't need it. We just need the content of the event, and that should be encrypted. We just remove all of the state events. We'll just put them into somewhere else in state, because especially the membership events, who needs 150,000 memberships in a room if we can solve it some other way? We'll just save a lot of effort on the server side and make everything possibly more efficient. We'll just get rid of permissions for now because it's complicated, and we'll just figure out how to solve that later. So let's take this as our working theory. Let's start with step one, make it a bit simpler. We'll just build a centralized solution for now for MLS on top of Matrix. We we'll define one server that orders our handshake messages, and only that server can send these commit events that change the membership in the room. Every other server can work decentralized, but it can only send messages, not change the membership in the room. This is not great because we're restricting what the server can do, but this is just step one, so maybe this is fine. We don't have really do any permission management, so in theory any member can invite people into the group. Again, not great, but this is just step one, so we'll just ignore it. We don't have any way to kick a user from the group on the server side, or at least tell the server about it, or enforce any kind of other permissions. We'll just kick them from the MLS group. They won't be able to see messages anymore, but they can still see that we are sending messages. Again, not ideal. We're still leaking metadata, but we'll just take this as a working theory. And for state events, for the room name and whatever, we'll just put it into the group context, don't tell Matrix about it, and that way we have basically encrypted state events, and we can still set a room name. That's somewhat easy to build. It takes a bit of effort to implement, but that's something we can do with MLS as it is without doing any changes. It does need a lot of changes to Matrix, but it's something that we can do. And then it has somewhat nice properties on the metadata protection. The server doesn't know who's in the room anymore. It can't tell you. So, well, we protect a lot more metadata now. It also can't tell you the name of the room or something. So if you ask it, well, you won't get any help from it. But on the other hand, well, it's this metadata is now not exposed anymore. So we kind of now have sealed senders for Matrix and stuff, and it's kind of cool. But we lost a lot on the way. So let's go a step further and try to fix some of that again. In this case now, instead of just breaking Matrix, we also break MLS by taking away some of the secrecy properties so that we get possibly decentralization back. In this case, we'll just do the complicated part that is very hard to get right on the server. We'll just do that now on the client side, so a lot more people have to implement it. Well, the server can't see the state way anymore, so it can't do this a lot of the state resolution anymore. So we just have to do a lot of that on the client side. So the clients now just have to keep all of the old commit events, so that they can then see, well, there were two conflicting commit events, and they will need to figure out which one of them was the right commit event. To be able to resolve that, as I said before, for Matrix, you have like the power levels of the admins. In this case, we basically only need power levels for servers. So we just define a list of servers, and the server that is higher in the list will win in a state conflict. So, and that's a way we can define which server is more trusted and predictably resolve those conflicts. Then if your change got basically state resolved out that you did for the commit event, you will just have to do the same change again. Like you invited Bob to the group, someone else decided to invite Alice instead, and won because they were on the higher power server. You will just have to invite Bob again into the group, which is what I basically meant with you have to do some of the state resolution on the client side. This is a bit of effort and probably very error prone, but in this case we basically now have some decentralization again. Obviously there's a power relationship between the servers, but any server can send commit events, and as long as the other server doesn't do it at the same time, we have some amount of decentralization. Now, ideally, we can also somehow force the servers to not go back on their word, because then we would have to keep even more old commit events around. And that could then improve the solution a bit. Or we could just say, well, if someone had a power level already in the server, they can never reduce that power level anymore, and then we don't need to ensure that we can't go back, and that could also be an alternative there. But this is not great yet. Now we basically we broke some of the MLS secrecy, and maybe we can do a bit better still. So how do we fix this basically unbounded forward secrecy problem where we need to keep all the old commit events around forever, which is basically one of the things that the original DMLS proposal kind of did, and which is why the IETF really didn't like it, because it said, well, you're giving up all forward secrecy. That's not that's some property we explicitly want from MLS. Because we also don't want it. We don't want an old device to be able to decrypt all of the future if it was compromised, for example. So what if we just add a time limit to devices? We say, okay, if this device wasn't online for 30 days, and it's for that reason also didn't add any new entropy to the group by updating its secrets, basically, then we'll just consider it not part of the room anymore. That way, we basically bound the secrecy problems we have to a predictable time span. It's also very easy to explain then why you might not be able to decrypt the message anymore. And maybe we just then find a cheap way to add those devices back if they actually come online. Like maybe you had your phone forgotten at home and you went on a travel, and then but you did have your laptop with you, and you just then add the phone back as soon as you get back from your holidays, and it can read all the messages. Maybe the usability of that would actually be fine. We could also then even go a step further and say, okay, we do some slight changes to MLS where we basically have forward progress per server, because as soon as we heard back from a specific server, we can know that it received a certain commit, and we don't need to keep around certain old secrets to be able to resolve state anymore. So and there's actually a proposal about that. It's also called DMLS, so don't get confused with DMLS, DMLS, and DMLS. But one of them basically does like some punctuable random functions. I don't know much about cryptography, so I can't really tell you specifically how it works or how actually the proper name for that is. But it basically allows you to throw away some keys for a certain set of users that you know are one server, and not throw it away for other sets of users. So it basically moves the forward secrecy partially forward for just on a per server basis, and that's still compromising secrecy a bit, but it's compromising it a bit less. And on the other side, we get some decentralization back for that. So maybe that's the compromise we need to do on Matrix, and maybe that's enough for us, and we just say, well, make sure that your servers regularly sends us a ping back, and that way we can make it secure to a bounded time value. The problem is we still have no permission control. So maybe how can we solve that without exposing which senders and users are on the in the group? Maybe instead of having a list of users that can do admin actions, we instead define a set of signing keys basically that can do admin actions. And when you do an admin action, you need to expose that you can do that admin action by adding a special signature. That way you don't necessarily tell everybody who can do this admin action, but you just expose it when someone does an admin action, and the server can't even see who sent that message, just that the signature is correct. So we don't need to expose as much information to do certain permission management. Now, this is very early in the state that we're looking at that, but maybe that could be an alternative to basically do state resolution without knowing about the having to expose so much metadata. And in theory, MLS can give us some hand-holding there, because it allows us to also derive secrets for a specific subset of users, and maybe we can reuse that somehow to then define those signing keys that we have. And maybe then, instead of having to do state resolution based on looking at all the events, we just need to look at a certain set of rotating secrets, and maybe that can actually make our state resolution a bit more efficient. But again, this is early state, so I don't really know if that actually works or not. So some open questions. Can we even make that work? There were a lot of theories, and some of the things we already tried out, but obviously that needs a lot more work to actually figure out if stuff is feasible. And also there are some security trade-offs that I touched on, but that doesn't mean that we actually understood all of them. So if we actually propose such a system, we obviously need to look at that in depth and actually clarify what those security trade-offs are. Can we improve state resolution in that way? Maybe that is actually something that would benefit Matrix in general. Maybe we would then want to encrypt all the rooms because it's just more efficient to do state resolution that way. No idea yet, but maybe just rethinking some of the approaches there can also make Matrix better by taking some ideas from MLS, basically. Then a big one is, okay, what's the usability like if you have basically rooms encrypted that way and then bounded time on how long a device can be offline? A lot of that stuff you actually need to test, because it's hard to, like, you can say, well, this is usable, but if a crypto person says that and then you give it to some doctor in a hospital, they will have a very different idea, so all of a sudden, how usable that system is. And another thing is, maybe we can decouple this directory service that Matrix basically is and the history sharing service that Matrix basically is. And if they don't exchange information, maybe that can provide us more anonymity in the system. Obviously, some people could still combine the data if they can look at both of the services. But if you have one service that basically tells you this is the user, and the history service never knows about that information, or the delivery service, or whatever MLS calls it, then maybe this actually gives us really nice privacy guarantees. Maybe, and there's possibly also some other, that's a terrible type. So maybe we could also build some other cool use cases with that. For example, you might have heard about these element calls and group calls and whatever, and that you want to do that encrypted so that nobody can snoop on what you're talking about. But exchanging the key is actually a bit of a difficult problem. There were several approaches discussed on it. I think they actually have found a good solution now. But maybe if we used MLS, we could just derive another key for the for the call and have basically zero latency to set up the call, and everybody in the group can just magically decrypt the streams. It has some trade-offs. Maybe you don't want to be able to, people to be able to decrypt the streams if they don't actually join the call, but it's one possible use case. We could also use it that we basically then have our room membership and can use it to authenticate against a third-party service. Maybe you have a widget that only should work for members of the group, even though it's hosted on some HTTP server. If we can steal some keys from the MLS group and use that for authentication against other services, maybe that would actually be cool. Everybody in your Matrix room can access the shared GitHub repository where you have some additional documentation. Would be a cool use case, so maybe that would be a benefit of using MLS as well. And also, since we got rid of the sender, maybe it's now easier to move accounts between servers, especially if we move out the directory service. Then we just need to update the link on the directory service, but in theory we are not really tied to a server as much anymore. So maybe that can also give us account portability, and all the people who are registered originally on matrix.org can finally move to their own servers that they always wanted to move to but didn't want to go through some migration tool. That was a lot of talk. Again, I didn't provide you any actual solutions, probably more questions than answers as well. But that's basically what I had prepared, and I think I'm all out of time.
Thank you. We have actually 10 minutes for Q&A. So if you have any question, please raise your hand. And if you watch from home, you can write in the Matrix room from this physical room, and I will review a question for you. Yes.
Hello. So what the open MSC that there is at the moment, what is that proposing in relation to your kind of multiple steps?
So
not familiar with the MSC.
The BWI proposal that's currently open is basically somewhere between step 1 here and step 2. It basically defines a list of servers that can send the commit messages, and if you only put one server there, then you basically have the step 1 because it's basically centralized. If you put 2 servers there, you move a bit more into this direction, but not completely yet because there's no client-side state resolution in it currently.
Thank you. Next question.
Hi, 2 questions if I may. First, you were talking previously about DMLS, and DMLS. I think we heard the MSC numbers for the first 2 DMLSs on the previous talk with braids. And the third DMLS with puncturable random functions. What's the MSC for it, if it exists?
Well, the DMLS proposals aren't actually really, well, I think maybe one of them was an MSC, but there are updates to the IETF standard. So they are IETF drafts. So they have some other name. I don't have them on the top of my head, but if you look through the IETF draft, there's a proposal link basically, and there the different ones are listed.
And the second one, in the keynote talk with Matthew, he talked about work on encrypted state, and this is brushing awfully close. Has there been some cooperation between the encrypted state work Matthew was talking about and the MLS work, which also apparently includes encrypted state?
For the most recent one, I don't think so. I think that was more of a, I don't remember the context at all, but I think it was more of a student or something working on a proposal there. And again, this one for me still has the problem that you have the different lifetimes for state events and the messages. And I opened a comment about it, but it doesn't intend to address it at all for now. So yeah, there wasn't really much collaboration on the latest proposal, and again, I think it still has the open issue that all the previous ones had. So,
okay, got it. Oh, thank you.
Thank you. Is there any other question? Yes, in the back.
Hi, Matthew here. I just wanted to chip in the other side of the answer to that one, which is that there are basically 2 totally different paths here between the radical approach that Nico has laid out here and the more incremental approach where you take Matrix as it is today, you do MSC 3414, which is the encrypted state event stuff that Sky did, and iterate towards something that looks very similar as an end goal. And the question is, do you start off by removing senders and doing the sort of step 1 there, or do you do that later on in the process? The other comment is on DMLS, if you really, unless somebody caves and renames their protocol, the way you tell them apart is that the one that we did as Element and the Matrix Foundation is decentralized with an S because we're British. And then the Phoenix one, which is riffing on that, which actually bounced via Amazon and Wicker. So they did a version called FRCGKA, Fort Resilient Continuous Group Key Agreement or something. Then bounced back into Phoenix. They'd called it decentralized MLS with a Z. And then you've got distributed MLS, which is the thing that AT Proto have. And I think those are all the ones. So they do have different names, even if they begin with a D. Sorry, not a question, just a comment. I'm that guy.
I think the original one by Matrix also has a lowercase d in the abbreviation, so maybe that also helps. But
yeah, absolutely. Not to be confused with DTNS.
You could also look at the authors.
Thank you. Any other question? Yes?
Yep. Hi, everyone. Question just about the backward compatibility, because I mean, this is a lot of steps and a lot of changes that will happen back in the servers. But if, how will be the backward compatibility handled in the future when releasing this? Because I guess a server that is implementing this whole DMLS stuff will not be compatible or will not be able to share information to old ones. So I'm also thinking about Room, Tombstone, etc. in the future.
So in my opinion, this wouldn't be a backward compatible change because you want to have a different encryption anyway. So if you already need to do that, you can possibly do also some other breaking changes. But you should still be able to upgrade a room basically to that version. And also you can kind of keep the federation APIs very similar. So the transactions, you can still wrap them into a HTTP transaction. And you can keep a lot of the client APIs similar, because even if the server doesn't know about the room you're in, in sliding sync, you could just tell it, sync me these rooms in like an extension, and otherwise use basically the same API shape with some restrictions that you have no state anymore. So you could make a lot of the APIs somewhat compatible, that they work across the different versions, but the actual room would not be compatible, and you would then have breaking changes. But we also kind of have a versioning system in the Matrix for room versions, and they are not compatible. So maybe sometimes doing a bigger breaking change for to then get a lot of benefits out of it is then worth it.
Thank you. Any other question? Then please give another warm applause.